A research team probing the properties of a semiconductor combined with a novel thin oxide film have observed a surprising new source of conductivity from oxygen atoms trapped inside. The research finding is described in detail in the journal Physical Review Materials. The discovery has broad implications for understanding the role of thin oxide films in future semiconductor design and manufacture. Modern electronic devices use both N and P-type silicon-based materials. But there is ongoing interest in developing other types of semiconductors. Chambers and his team were testing germanium in combination with a specialized thin crystalline film of lanthanum strontium zirconium titanium oxide, LSZTO. "We are reporting on a powerful tool for probing semiconductor structure and function," said Chambers. This was a big surprise. Using the diamond light source on the Harwell Science and Innovation Campus in Oxfordshire, England, the research team discovered they could learn a great deal more about the electronic properties of the germanium, LSZTO system than was possible using the typical methods. When we tried to probe the material with conventional techniques, the much higher conductivity of germanium essentially caused a short circuit, Chambers said. As a result, we could learn something about the electronic properties of the Ge, which we already know a lot about, but nothing about the properties of the LSZTO film or the interface between the LSZTO film and the germanium, which we suspected might be very interesting and possibly useful for tech. Our results were best interpreted in terms of oxygen impurities in the germanium being responsible for a very interesting effect, Chambers said. The oxygen atoms near the interface donate electrons to the LSZTO film, creating holes, or the absence of electrons, in the germanium within a few atomic layers of the interface. These specialized holes resulted in behavior that totally eclipsed the semiconducting properties of both N and P-type germanium in the different samples we prepared. This, too, was a big surprise. The interface, where the thin film oxide and the base semiconductor come together, is where interesting semiconducting properties often emerge. The challenge, according to Chambers, is to learn how to control the fascinating and potentially useful electric fields that forms at these interfaces by modifying the electric field at the surface. While the samples used in this research do not likely have the immediate potential for commercial use, the techniques and scientific discoveries made are expected to pay dividends in the longer term, Chambers said. The new scientific knowledge will help materials scientists and physicists better understand how to design new semiconductor material systems with useful properties. Some experiments and sample preparation were performed at the Environmental Molecular Sciences Laboratory, a Department of Energy Office of Science user facility located at PNNL. https://ift.tt wvqukkn. Accessed March 1, 2022. Please support my channel to grow by pressing subscribe button and the bell icon. We will notify you technological news. Thank you.